So for number 38, we've got a hockey puck that's hit on a frozen lake. Initially moving at 12 meters per second, 5 seconds later it speeds down to 6. First question, what's its average acceleration? Well, just get started. I'm just going to make the mass of this puck m, just so we can talk about it a little bit later when we have to figure out forces. And drawing the forces on it, we've got force of gravity, normal force, and if the puck's traveling to the right, the force of friction would be to the left. O is acting against the motion, or potential motion. Kinetic friction this time because we're moving between two moving surfaces. For the acceleration, it's actually pretty straightforward. Acceleration is defined as the change of velocity over the change in time. In this case, final velocity 6 minus initial velocity 12 over 5 seconds. The acceleration is negative 1.2 meters per second squared. Now, before we go to the next part here, how much force, or what's the net force on this puck? Well, we can use Newton's second law. We know it's accelerating at 1.2 meters per second squared, towards the left, actually, in this case. And so we can very quickly figure out the net force on it must be negative 1.2 times m. And that what's producing that? It's got to be the force of kinetic friction. That is the net force on this puck. Again, just a quick side note here. I used m as a variable. What can you do if you don't know the mass of the puck? You can actually choose your own mass, like 1. And actually, in this case, then we would have gotten negative 1.2 newtons. M is equal to 1. And that would have been the force of kinetic friction. You're like, Mr. Clemmer, can you just do that? Yep. As long as they don't give us a mass, it means the mass is irrelevant. It won't affect your answer. Once we know that, we can actually identify a few things here on the graph. If the mass of the puck is m, force of gravity would be 9.8 times m. Normal force is also going to be 9.8 times m. And the force of kinetic friction now we know is 1.2 m. You're like, what happened to the negative sign? We know it's acting against the motion. The net force is in the opposite direction of the initial velocity. The question, though, we're trying to solve in B is what's the coefficient of kinetic friction? Well, if you remember, the force of kinetic friction is equal to mu sub k, the coefficient of kinetic friction, times the normal force. Plugging in our numbers, we know the force of kinetic friction is 1.2. I dropped the negative sign. I'm only interested in the magnitude. Equals the coefficient of friction, mu sub k, times the normal force, which we know is 9.8 m. Solving it, you'll find the coefficient of friction is 0.122. No units, coefficient of friction is a unitless quantity. Finally, part C, how far does the puck travel during the 5-second interval? Just using one of your kinematics equations. In this case, the initial velocity is 12, time is 5, acceleration negative 1.2. Are there other ways of solving this? Yeah, you could have done average velocity times time, or whichever you like. In any case, you'll discover that the distance is 45.